Okay. So what it tells us is we have x has a normal distribution with 3.2 and variance 6.5. Y has a normal distribution with negative 2.1 and 3.5. And Z has a normal distribution with 12 and 7.5. And they are independent random variables. For E, we're supposed to find the probability that the absolute value of x plus 6y plus z is greater than or equal to z, or greater than or equal to 2. Now again, I told you on this that when you look at the solutions manual, it makes this look really complicated. Okay? But we're not going to make it complicated. We're just going to say, okay, well, I have a new random variable, and I'm going to call it w, which is x plus 6y plus z. Let's say that's my new random variable. Okay, what I need to do is I need to find the new mean. Okay, so to find the new mean, okay, well, let's write it as the expected value of x plus 6y plus z, and just use our rules for expected value that we memorized a while ago. So this is the expected value of x plus 6 times the expected value of y plus the expected value of z. Correct? That's what makes sense to do for our expected values. So this is 3.2 plus 6 times negative 2.1 plus 12. So 2.6. And we need to find the standard deviation for w. It's usually easier if we start by finding the variance for w first, because we know the variance rules. So this is the variance of x plus 6y plus z. Okay, so what happens with our variance? We know that if they're independent random variables, which they are, we can just add the variances. So this would be the variance of x plus, what happens with my 6? It comes out as a 6 squared. Variance of y plus variance of z. Let's see, so my variance for x was 6.5, variance for y was 3.5, oh, but I was supposed to times it by 6 squared, and variance of z was 7.5. So 140 is my new variance, but I also need to find my new standard deviation. So I just take the square root of the variance. So 11.832. Now again, when I do these problems, I think I find it easiest to kind of do it step by step. So the first thing I do is I find my new mean and my new variance just by using our old rules. And then I try and use what I know about the normal distribution. Okay. So according to what we learned in section 5.2, we know that any combination of normal random variables, any linear combination, is still going to be normally distributed. So W is still going to be normal. And we found the new mean and the new variance. Once we know our new mean and variance, now let's try and find the probability. So instead of the absolute value of x plus 6y plus z, let's rewrite it as the probability of the absolute value of w is greater than or equal to 2. Once I write it like this, do you know how to find that probability from section 5.1? And it doesn't look so complicated anymore. How did we find this probability yesterday when we were talking about section 5.1? I wanted to first get rid of the absolute value. So if the absolute value of w is greater than or equal to 2, so like here's my 2, here's my negative 2. Am I looking for the area in between or the area on the outsides? Outsides, because the absolute value is greater than or equal to 2. So I'm looking for the probability that W is less than or equal to negative 2, or W is greater than or equal to positive 2. Before I can do this, I need to standardize. So it's going to be W minus the mean of W over the standard deviation of W. Okay. Is less than or equal to negative 2. Or W minus the mean of W over standard deviation of W is greater than or equal to, oh, what did I miss? I forgot to actually standardize the number. So negative 2 minus my mean of 2.6 divided by my standard deviation of 11.832. And 2 minus 2.6 divided by 11.832. Okay, so this is going to be the probability that Z is less than or equal to negative 0.39, or Z is greater than or equal to negative 0.05. Okay. Now, have you guys found anything wrong in my work so far? And so if I was to draw a new graph with my actual Z values, these are my Z values, so I want less than or equal to negative 0.39, okay, or greater than or equal to negative 0.05. Okay. So if I look up negative 0.39 on my Z table, it gives me 0.3483. Okay. If I look up negative 0.05 on my Z table, it gives me 0.4801. But that's the area to the left, and I want the area to the right. So I need to do a 1 minus the 0.4801, which gives me 0.5199. Okay, so this total probability over here is 0.3483 plus 0.5199. Which gives me 0.8682. Okay. You'll notice in the solutions manual that they have a 0.8689, which probably means that they just didn't have to round their Z values to use the table. They probably used the computer. Okay. So, questions on this problem? Okay. Again, what we learned from this problem is you start off with something that looks really nasty. Ignore it for a minute. Just look at, say I have a new random variable W, find your new mean, your new standard deviation, and then just write it as the probability that absolute value of W is greater than or equal to 2, and it suddenly looks a lot simpler. At least I think it does. So, questions here?
Could you run through how you got that 2.4 or 0.3483?
Oh, 0.3483. So my Z value is negative 0.39, and I was looking for the area to the left. Okay. So if I go to my Z table, I'm looking for negative 0.39. So negative 0.3 down the side, and then go across to the 0.09 in the hundredths place, gives me my 0.3483. Okay. And then when I try and look at my 0.05, I go to my negative 0.00, or 0.0, and then go across to the 5/100ths place. Gives me that the area to the left of that was 0.4801, and I did a 1 minus that.
Is that showing this to the left?
Yep, because this always shows the area to the left.